Hello all, welcome to Vishnu's lectures. So today we are going to discuss about data types. So we already covered character data type in last lectures. So today we are going to discuss about remaining data types. Okay. So actually data types are mainly categorized into three types: primitive data type, derived data type, user defined data type. So under primitive data types, what are the primitive data types? Integer, character, float, double, and void. So all these are treated as primitive data types. Primitive data types means predefined data types. Okay. Next, we have derived data types like arrays, strings, pointers, and user defined data type like structures, union, typedef, and enum. So, but today we are going to discuss mainly about primitive data types. Derived data types and user defined data types are somewhat advanced concepts that we will discuss later in upcoming classes. Okay. So now we'll discuss about primitive data types. Okay. So primitive data types. Primitive data types means integral, like character, short int, integer, long int. So these are comes under integral. So in character, 1 byte means character occupies 1 byte. 1 byte equal to 8 bits. 1 byte equal to 8 bits. This I already told, I think. So 1 byte equal to 8 bits. And short integer. Short integer is 2 bytes. 2 bytes equal to 16 bits. Integer. Integer is 2 bytes or 4 bytes, depends upon platform. In 64-bit compiler, it is 4 bytes. In 32-bit compiler, it is 2 bytes. Okay. Let's say I'm using 64-bit compiler, so it is 4 bytes. 4 bytes in the sense 32 bits. Getting my point? So long int 8 bytes, long int 8 or 16. That depends. And real data type. Real means float, like 5.5, 6.5, like that. So float values are, we can say that float values as real type, real data type. So real data types examples are float, double, long double. These comes under real data type. Okay. Next. So now we'll discuss, already we discussed in last class about character. Now we'll discuss about in short integer. So short integer means occupies 2 bytes in the memory. 2 bytes equal to 16 bits. So 16 bits maximum value. 16 bits maximum value, how to calculate? You can simply write 2 power 16. So what is 2 power 16 value? 65536. So how many values it can able to store? Max to max 65536 is the maximum value we can able to store in 2 bytes location. Getting my point? Similarly, I already told you, for every data type, we have type modifiers: signed, unsigned. Signed means it accepts both positive and negative data. Unsigned means it accepts only positive data. Same here also. So signed means accepts both positive and negative data. Unsigned means accepts only positive data. So what is the range for signed character? How to decide this? So 65536 is the maximum value divided by 2. So 32768. So you have to store 32768 positive values, 32768 negative values, if you are talking about signed. Getting my point? So that's why the range for signed short integer is minus 32768 to plus 32767. Means here signed short int 32768 positive values, 32768 negative values. Unsigned short int range. Unsigned short int range means all are positive only. So 0 to 65535. Okay. Just I'm dividing the maximum capacity 65536 by 2, which is 32768. Means we have to divide equally 32768 positive values, 32768 negative values, which comes under signed. If it is unsigned, no problem. All are positive. 0 to 65535 only. Total 65536 values. Okay. See here. This is the flowchart for signed short int. This is the flowchart for unsigned short int, right side part. Okay. Now we will enter into the subject. Okay. See here. Just I'm writing some code, simple code. For suppose int main function short int x equal to, let's say 32766 semicolon. So before storing any value, you have to consider that this x is which data type. First of all, x is which data type? X is short int data type. Okay, x is short int data type. Signed or unsigned? Sir, you not specifying, no, sir, here signed or unsigned. Even though if I'm not specified, by default it is stated as signed. By default, all data types are treated as signed. So now x belongs to signed short int. So if it belongs to signed short int, then tell me what is the capacity of x. So x can able to store these values because this is a signed short int range, signed short int flowchart. So what are the values the x can able to store? Minus 327682 plus 32767. Now tell me 32766 is existing in this range or not? 32766 is existing. So that 32766 can able to store in x. Getting my point? So what is the value stored in this x? 32766. So now printf, pf means just consider printf shortcut. So printf percentage hd comma x. Sir, why sir percentage hd? I already told you the format specifiers. The format specifier for signed short int is percentage hd. So the output printed as 32766. Getting my point? What if I take let's say one more example here. Same example only I'm taking. Let's say instead of 32766, let's take another number. What exactly? 32769. 32769. So I'm trying to store 32769 into the x variable, right? But is x able to store this 32769 into the x? Yes or no? It is not able to store because first of all tell me x belongs to which data type? Short integer. Signed or unsigned? Signed. So what is the range for signed short int? The range for signed short int is from minus 32768 plus 32767. But what is the value you are trying to store here? 32769. Is 32769 existing in this range? This signed short int range? Not existing. But consider who replaced this 32769 place? Means see here this is 32766, here 32767. After 32767, who has to come? 32768 has to come. Who replaced this 32768 place? Minus 32768 will be replaced. Next, who has to come? 32769 has to come here. 32769. Who replaced this 32769 means plus 32769 place? Minus 32767. So instead of storing 32769, who replaced this place? Minus 32767. So what is the value stored in x means? Minus 32767 will be stored instead of 32769. Getting my point? Similarly, here also main function unsigned short int y equal to Let's take 65535. So first of all, tell me y belongs to which data type? Short int. Y belongs to short int. Signed or unsigned? Unsigned. Unsigned means, so the y can able to store these values 0 to 65535 values. So what is the taken value here? 65535 only. Is 65535 is existing in unsigned short int flowchart or not? Yes or no? Existing. If it is existing, what is the value can able to store? Same value. What is the y can hold now? 65535 only. Can I print this? Yes. How to print it? Printf. Printf. Just a minute. So printf percentage. What I have to take? Percentage hu comma y. Percentage hu comma y. Why hu? Because for unsigned short int, the format specifier is percentage hu. Getting my point? So what is the value printed? Y printed as 65535 only. Now let's take 6553 something 38. Now let's take 65538. Now is y can able to store 65538 or not? No. Why, sir? Because let's tell me y belongs to which data type? Y belongs to short int data type. Okay, y belongs to short int. Signed or unsigned? Unsigned. Okay, so now y belongs to unsigned short int. What is the range for unsigned short int? The range for unsigned short int is from 0 to 65535. But what is the value I have taken here? I have taken value as 65538. Is 65538 existing in this range? No. Who replaced this 65538 place? Let's say 65534, 65535, 65536 is replaced by 0, 371, 382. So 65538 in place of 65538. After the flow, this is exceeding this range, and in place of 65538, 2 will be there. So what is the value stored in y? The value stored in y is 2 only. So whenever you try to print y value, 2 is going to be printed. Getting my point? This we will see practically actually. Okay, now? Okay, let's open Ubuntu. Vi space search rt1.c hash include stdio.h hash include stdio.h. Just a second. Vi space search rt1.c insert hash hash include stdio.h. Okay, int main function. Why to means why to learn all these concepts? Because if you go to any exam, they will give this type of snippets, so you have to predict the outputs. Getting my point? If they want to give some questions on data types, then they will give this type of snippets only. You should know this concept if you want to answer this. See here, if I write simply short int x equal to 32768. I already told this 32768 is not existing in signed short int range. I'm not mentioning signed or unsigned. So by default, this x belongs to signed only. So in place of 32768, who is there? In place of 32768, who is there? What is the value I have taken? Let's take 32769. Who is there? Minus 32767. So minus 32767 is going to be stored if I take 32769. So here what I'm doing, let's take 32769 and printf percentage hd slash n comma x, because format specifier for short int is percentage hd. Okay, now just compile and execute. Dot slash a dot out. So minus 32767 is the answer. But what if I take 32767? Now tell me, 32767 is existing in the signed short int range or not? Existing. So if it is existing, same value can able to store in X. See here, you have to observe the flow chart, then only you can able to understand. See, 32767 is existing. What if I take my 32768? If I take 32768, then what happened? Is 32768 existing in the range signed? Is 32768 is existing in the signed short int range or not? Not existing. Who is there in place of 32768? See here. In signed short int range, who is replaced? So 32768 in place of 32768 minus 32768 is existing. So now what is the output printed here? Minus 32768. Similarly, we'll work on now unsigned short int. What is the range for unsigned short int? The range for unsigned short int is from 0 to 65535. Let's take unsigned short int. So in unsigned short int, the range is from 0 to 65535. So you can store any value between 0 to 65535. Let's take 65535. 65535 and print this 65535 in terms of unsigned short int or signed short int. Unsigned short int. So what is the format specifier for unsigned short int? Percentage HU. So now tell me, is 65535 is going to be printed or not? First of all, tell me X can able to store 65535 or not? Yes, because X belongs to short int. Which short int? Unsigned short int. So unsigned short int range is from 0 to 65535. So X can able to store 65535 happily. So X will print as 65535. See here. What if I take 65536? What if I take 65536? What if I take 65536? Is 65536 existing in the range or not? In unsigned short int range or not? See here. In unsigned short int range, 65536 is existing or not existing? See here. After 65535, in place of 65536, what is there? 0 is there. In place of 65537, 1 is there. So if you try to store 65536, what is the actual value going to be stored in X? 0. 65536 will not store. Instead of 65536, 0 will store. And I'm printing this X value. Getting my point? So now the value is printed as 0. Okay. Next, sir, if I take long value, see, actually, if the taken value is not within the range, simply apply the formula taken value minus total values. How many total values are there in unsigned shorthand? 65536 values are there. So what is the taken value? 65536. So 65536 minus 65536. Taken value minus total value. That is the formula. So 65536 minus 65536, which is 0. So if I take, let's say, 65540, is 65540 available in the unsigned shortened range or not? Not available. If not available, what do you have to do? Simply apply the formula. What is the formula? Taken value. What is the taken value? 65540 minus total values. How many total values in that range in the flow chart? 65536. So 40 minus 36. 65540 minus 65536, which is 4 only. Getting my point? Which is 4 only. But this is not the subject actually. This anybody can learn, but we will discuss now very important and confusing concepts. That is our motto. Okay. See here. That is our motto means what we are going to discuss now. We are going to discuss importance of format specifiers. This is a confusing point actually. So what is the importance of format specifiers? That is our topic now. Okay. So importance of format specifiers. See here. This is very interesting concept. See here. What I'm going to do here, just take 65534 or 24, whatever it is. Is 65524 existing in the range or not? Existing. Okay. So X can able to store 65524 or not? Yes, because X belongs to shortened. Which shortened? Unsigned shortened. So it can able to store 65524 because it is within the range. But what I'm doing here, just instead of using percentage HU as a format specifier, I'm using percentage HD. Instead of using percentage HU as a format specifier, I'm using percentage HD. So what it means? You are trying to print 65524 in signed shortened range. Getting my point? Now, X is holding 65524, okay. But you are trying to print that 65524, which is X in terms of percentage HD. Percentage HD means signed shortened. Now tell me, 65524 is existing in signed shortened? No, not existing. Then what happened? See here. Just I'm changing the format specifier. I'm not using percentage HU. What I'm using here? Percentage HD. I'm using signed shortened ka format specifier. I'm not using unsigned short integer ka format specifier. Now see the result. See here. So it's not printing the taken value. It is printing minus 12. How it is printing minus 12? Because if it is 65524, you have to take, if it is percentage HD, you have to take what? You have to take the signed shortened range. Percentage HD means signed shortened range. So in place of 65524, who will be there in signed shortened range? Minus 12 will be there. Okay, we'll do one thing. In place of 65524, we'll take 65535. So now tell me, X can able to store 65535 or not? How to do that? X belongs to which data type? Short integer. Signed or unsigned? Unsigned. So X can happily store 65535 because it is within the range. Fine. But you are printing that X value in terms of signed shortened. Getting my point? Signed shortened you are printing. But 65535 is existing in signed shortened. Don't confuse. Whenever you are printing this, you are printing in terms of signed shortened. Getting my point? You are printing in terms of signed shortened. This percentage HD represents signed. Okay, 65535 ka value is what in terms of signed? That we will discuss now. See here, -1. 65535 in signed is -1. See here. Observe this. 65535 in place of 0, 65535. If it is signed means both positive and negative. So 1, 2, 3, 4 like that. 0, 1, 2, 3, 4. Before 0, who will be there? If it is signed means both positive and negative. -1 will be there here. Getting my point? Here -2 will be there. I am talking about signed shortened. Here -3 will be there in terms of signed shortened. So that's why in place of 65535 -1 will come. In place of 65534 -2 will come. In place of 65533 -3 will come like that. Getting my point or not? If I take 65534, then -2 will come. Because you are printing in terms of signed shortened. Observe here. 65535 and 65534 should be -2. Okay. But if I use format specifier, correct format specifier, this data is unsigned shortened, so you have to use the respective format specifier only. So if I use same format specifier, then no problem. Getting my point? Then printing same. So like that. Similarly, remaining data type. What is the next data type? Integer data type. For integer data type, how many bytes? 4 bytes. Okay. 4 bytes means how many bits? 32 bits. See here. Now next data type is integer. So integer means how many bytes? 4 bytes. 4 bytes means 32 bits. So what is the maximum value? Can say maximum value is 2 power 32. So it is very lengthy number you will get. That many values you can able to store. Like 4 giga. It belongs to 4 giga. So unsigned integer. Unsigned integer. Unsigned integer is from 0 to 4 giga. Signed integer. Signed integer is from, so 4 giga divided by 2, 2 giga. So now for signed integer, what is the range? -2 giga to +2 giga. Getting my point? So if you want to write flowchart, simply write this like this. 0 to 4 giga. Because unsigned means all are positive only. 1, 2, 3, 4, like this. So if I take signed integer, so this will be minus 2 giga to plus 2 giga. Getting my point? What is the format specifier for this? For unsigned int? Simply percentage u. Here, percentage d. This is signed integer. Getting my point? So, see here. So how to know, sir, what is the maximum value for integer? For that, what I will do here, see. Just a minute. Unsigned int x equal to -1. -1 means maximum value in unsigned integer. So simply printf percentage u comma x. So how to analyze this program means, first of all, x belongs to which data type? X belongs to integer. So integer. If it is integer, belongs to signed or unsigned, that you have to confirm. Signed or unsigned? Unsigned. If it is unsigned integer, what is the range? 0 to 4 giga values. All are positive, but you are trying to store -1. -1 comes before 0. Getting my point? -1 is before 0. If it is unsigned integer range, in place of -1, 4 giga value will be there. See this diagram. See, in place of before 0, who is there? So who replaced -1 place? This is -1 actually. So 4 giga will be replaced. If you try to store 4 giga value, if you try to store 4 giga value, then what happened? If you try to store -1 in unsigned, then 4 giga will be replaced. Getting my point? So now you will get 4 giga value because you are printing in terms of unsigned. Unsigned never prints. Unsigned never prints. Unsigned never prints what? Negative. Unsigned never prints negative data. Getting my point or not? Unsigned never prints negative data. Before token expect. Yes. I must close comma x. Okay, 2 times I close this. So this is the 4 giga value. This is the 4 giga, 0 to 4 giga. These many numbers it can able to store. Getting my point? Okay. And for suppose if I take some values like int x equal to 20, unsigned int x equal to 20. If I take percentage x, then what is the meaning of this percentage x? Print this 20 in terms of, print this 20 in terms of hexadecimal. So what is the value printed as? $14. Yeah. Thank you.